This video involves some slightly heavier coding for anyone that wants to get really fussy about their tyre tracks. Right now we're stamping our tyre track into the scene at the exact same size every time, which you might notice does look a little bit weird if we're going too slow because they all bunch up, or if we're going too fast because you'll start to see gaps between them. We also sometimes get a bit of a staircase happening if we drift too quickly because our speed doesn't always match the direction that we want the tracks to be facing. So we can solve all three of these problems at the same time by keeping track of our last position where we wanted to place a track and the new position where we wanted to place a track. Then we'll put the track right between those two and we'll scale it so that one end touches the new position and the other end touches the old position. We can do that the whole way through. We'll get between an old and a new position, between an old and a new position, between an old and a new position, and we'll always have perfectly placed tracks that have been scaled to fill all the gaps. We just have to remember that every time we get a new position, after we're finished doing the scaling, then we save it into the old position so it can be used as the old position for the next one. And we work our way all through from the start of the track to the end of the track. Before we write any of the code for this, we're first going to go back to our track scene and set the Y size of our track scene back to 1. It will make our tyre look quite stretched, but that's okay because we're going to be doing this scaling through code. Now for the code. We start by going all the way to the top of the script and adding a variable for our old left position and another variable for our old right position so that we can set them every time we add a new piece of track. Then we go down to our is left ray colliding section, and at the very start of it we get a new left position, which will be this position here, left ray dot get collision point, and at the end of the left ray is colliding block of code we set the old left position to that new left position. The way that this works means that we won't be able to create our first piece of track until we've already stored an old left position. So most of this code will need to go inside a block that says if old left. All of this code here will need to be indented, and just the line setting the old left position will be after the loop so that we get our first old left value filled in. Then the second time we come into this function, we'll also get a new left value, and we'll be able to use the old left value and the new left value to get the position of our track. Now we change the track's position to be halfway between old left and new left by writing old left plus new left divided by 2. That will get us our halfway position between those 2 points. We change the direction the track is looking at to be the new left position from the old left position, and we set our track.scale.z to be the length between our new left and old left position by writing new left minus old left dot length. Then we have to make the same changes to our right wheel. Add a new right. I'm going to set that to right ray collision point. This is all going to be in if old right. I'm going to set old right to new right. I'm going to change the position. I'm going to change the direction it's looking at. And I'm going to add a scale to the Z axis. And the final thing I need to do once my left code is looking nice and my right code is looking nice, as I need to remember that if I've decided to stop drawing tracks, I have to set old left and old right back to null. Otherwise, when I try to start drawing tracks a second time, I'm going to draw one big piece of track between my last set of skid tracks and my new set of skid tracks. So by setting them back to null, that means I won't be drawing this part here between my new value and the old value that we stored last time we drew the tracks. This is a lot of extra code to write for not much noticeable difference, but we'll play the game anyway so that you can see we should now have some slightly smoother tracks as we drift. And there we have it. That's our perfect drifting system in Godot.